In this video, I will be presenting my 5th lab report, Choose Your Own Adventure. So for this lab, I have decided to verify Newton's laws for myself by observing the motion of a ball thrown upward at an unknown angle. I can do this by creating models for predicted and real motion. So the steps I followed to do this experiment included identifying the system and the surroundings, and the second step was to apply the laws of physics, and the third was to compare predicted results with actual results. Now we'll go ahead and do the first step. This is part of the motion we will be observing. The mass of the baseball in this scenario is 0.27. Our system would be the ball. And the velocity, the initial position, was obtained from tracker, and the time step between frames was found to be 0.033 seconds. The readings from the tracker was recorded in a CSV file, and the first two readings were subtracted and then were divided by the time step to give the initial velocity. Now that we're done with the first step, we will go ahead and apply the law of physics. That's the second step. Now, according to Newton's first law of motion, an object moves in a straight line and at constant speed except to the extent that it interacts with other objects. So if our object was to move in a straight line without interacting with any other object, it would have moved in that direction with that speed. However, our object does interact with other objects. One of the components it interacts with is the Earth. And the force exerted by the Earth on the object is given by the formula that appears right now. The other component it interacts with is the air, and the force that the air exerts on the ball is given by the formula below, and the total force exerted on the ball is given by the formula to the left. Now what we want to do is find the position of the ball at every point of its trajectory. So in order to do this, we will now apply Newton's second law of motion. Now Newton's second law of motion says that dp by dt is equal to F net. So P final minus P initial should be equal to F net into dt. This means that mass into V final minus mass into V initial is equal to F net into dt, and V final minus V initial is equal to F net into dt by m, and V final is equal to V initial plus F net into dt by m. Now that we have V final, the position of the ball can be computed. It can be computed by using the formula position final is equal to V final into t plus position initial. Now we have finished applying the laws of physics. We will now plug in the formulas we just explained into a Python code which is shown over here. You may pause the video to view the code. Now we should compare predicted results with the actual results. Now I can show you the motion of the object. As you can see, the object seems to have a parabolic trajectory. And now in tracker, we take the positions of the ball, we plug it into a CSV code and make the VPython code read it. Now when we run our code, this is what happens. The green line represents the actual trajectory and the red line represents the predicted trajectory. As you can see, there are obviously a lot of discrepancies between the actual and predicted trajectories. This could be because of the angle of the camera distortion, my wrong computing of beam the drag force, human error, and many other factors. However, we can conclude from this result that that Newton's laws of motion have indeed been verified. Before I finish, I think it is important to answer one more thing. What if the ball had been thrown at a different velocity? Observe the trajectories shown here. In each case, the ball goes through a certain maximum height before its velocity decreases and it starts coming down. Well, if the velocity had been increased, this certain maximum height would have been greater than the maximum height that the ball just now displayed. Also, if you were ever like me and wondered what the ball would look like when there was no drag force opposing its motion, well, Here's what trajectory looks like. It is shown by the red line. Obviously, the ball changes position quite a bit because of drag force.